Given a part of the circle, how do you determine its center? And after finding the center, how are you going to find its radius and then the circumference and all that? So here we have a problem, right? A broken piece of a circular glass plate is given to us, and your task is to find the original size of the glass plate. So here, this is the glass plate, alright, and it's in fact a small piece out of the whole of a big glass plate, right? And you see an arc here, that's a part of a circle. So having known that part of a circle, how do you find its center? Okay, and what is the original size of this glass plate? We have to find. Okay, and before going into its solution, we need to know that in any circle, a perpendicular bisector drawn on the chord will pass through the center of the circle. So that is the information we need to know. Here we have a chord, this two endpoints A and B I'll call. AB is a chord, right? And this red dotted line is a perpendicular bisector, that is this point, I'll call it as a C. C is the midpoint of AB. Okay, and this line is a perpendicular bisector, and that perpendicular bisector passes through the center. And we'll prove it in a different video, but here right now, remember that a perpendicular bisector drawn on a chord in a given circle will always pass through its center. Okay, now going back to the scenario, this is the thing we have. A broken piece from a circular glass plate is given to us, and you are asked to find what is the original size of the glass plate. Alright, so now that I have here a part of such a circular glass plate, so this is the arc we have, that is the arc, and it's just a broken piece. Now we have to find what is the whole thing, what is the whole actual size of the glass plate, and of course we have to find the radius and all such things. Okay, now in order to find the center of the circle, just now we saw that you need to know what is the perpendicular bisector of the chord. So let us take 2 points here. We'll have one point on the circle, that's A, and other point to B I'll take here. A and B are 2 points on that arc, and you know that those 2 points, if I join on connecting those 2 points, we will get a chord. And I can start from B or take another point C, that's fine, and D is the 4th point. Join those 2 points again, so you have one more chord, CD. So AB is one chord and CD is the second chord. Now we will bisect them. We will draw a perpendicular bisector on this chord AB and also on the chord CD. Right, the first one. Now how do you draw a perpendicular bisector? You just have to keep your sharp point or metal point on one end point and take the radius of the compass, which is slightly more than half of this AB. Whatever is the measure of AB, say I'm taking slightly greater than, so that my 2 arcs will intersect. Now I'll draw one arc here and the other arc on this side, on both the sides of the chord AB. Now from B, I moved my center of the arc or this compass, that steel point, I bring it over here onto that A, and without changing the radius, I am drawing the arc. I have drawn those two arcs. Now it is intersecting at those 2 points, right? This is one point of intersection and this is another point of intersection. Now you just draw a line joining those 2 points of intersections. This line is nothing but your required perpendicular bisector. We can extend if we have to. Let me draw a slide some more. Okay. Now you have one perpendicular bisector on this chord AB. Now similarly, draw another perpendicular bisector. Make sure that you take a compass with the radius slightly greater than half of that chord. You got one more here. So these are the 2 arcs you have. Then from the other end point, this is one and second one. So you have your 2 points of intersections. Okay, that's over here one point and other point of intersection. Let me join those 2 points of intersections and extend so that this perpendicular bisector, second perpendicular bisector, will intersect the first perpendicular bisector at one particular point. Now you already know that a perpendicular bisector drawn on the chord will pass through the center of the circle. So somewhere on this perpendicular bisector you have the center of the circle. Similarly, somewhere on this perpendicular bisector you have the center of the circle. Now between these 2 perpendicular bisectors you are having only one point. That one point is common between those 2. Hence that particular point, I call it as P, must be the center of your circle. So this P will be your center. Now taking that as a center on any point of the circle, either A, B, C, D, anything you take, measure all the way up to that. See, now I have, it's here on A, exactly it is on B, C and D. So I'll just draw a circle passing through those points, and that was your first arc. So that piece now converted into a whole big circle. Now this whole thing is the original size of the circular glass plate, of which you have only this was the part you had. So from that small piece of this whole glass plate you could find its original size. Now if you want to find the radius, just measure it in inches. I'll take, it is how much? 3.2, 3.1, 3.2. Even this side you take, it will be exactly 3. I started from 4, it's all the way up to 7.2. The radius is equal to 3.2 inches. So using this radius you can find the circumference. C is equal to 2 pi r. Substitute the value of r, that is 3.2, you'll get the circumference. Or if you want to find the area, the formula is pi r square. Alright, so this is how you can find the whole of the circle or the circumference just by using a small part of the circle. Okay, alright, thank you.